Okay, hi everybody. Approaching to the end of FOSDEM, and today I'm going to update the talk I did back in the very prestigious Kernel event back in Tokyo. I did a similar talk there. I think most of the guys here in Europe might not be attend that conference. I'm going to repeat it, although it's online. But also, we give some updates since the 2 months talk in the December. Now is 1 month, and then we make it a lot of great progress. So today's talk is all about breaking the record. How do we get RISC-V upstreaming doing better than any other of the ISA, and trying to match of the x86 as much as we can. And I'm Liang. I'm the founder of DeepComputing. So actually, I'm a software guy. Before I earn all my money from software, and I'm VM guy, I'm compiler guys. I put most of the VM from the old day Java VM all to JavaScript to all the Dart, Go, whatever VM. I put most of the stuff. And then also a static compiler guy. I'm familiar with back in the old day the MIPS compiler called Open64. So I'm the founder of DeepComputing. I found the company, hardware company in COVID. And I'm a very serious software guy. I start to understand why Allen Key says that. So I earn all the money from software and losing all in hardware. It's very brutal. So, and I make laptops, RISC-V laptops. So this is the 2003, we make the most expensive RISC-V laptop in the world. Now it's in museums. So it's $5,000, and yeah, we didn't make a lot, and 100 pieces. Hopefully, it's better than. And then in 2024, I make a very affordable second generation laptop with 8-core, and then a tablet as well. So I start finding out, and the first ever time Ubuntu and Fedora give us support. And that's the beauty of RISC-V. And after a while, I start thinking about, I only care about RISC-V, I don't care about battery, I don't care about screen, I don't care about everything else, keyboard on the hardware. So, but when I do laptop, I start finding out that I lose so much money on the rest of the things, nothing to do with RISC-V. And I start partner with framework, so they have a booth there, so you can see they have a laptop can support multiple architecture. I think you guys should know about it. If you want to do kernel, you can port all different architecture from x86 to ARM to RISC-V. They one machine, they can support all the architectures with different motherboards. So do take a look. And then, although it's nothing to do with kernel, I will soon pass by this. Basically, it's very good for our European cultures. So it's DIY, fix it yourself, lasts forever. Very monumental. So, and then I did the first Roma framework motherboard for them. The same 4-core is around $150, 8 GB RAM. But now it's worth about probably $200 because the DDR price gone up crazy. So, and then last year we make another board with 64 DDR, and it double the price now. If whoever buy the first patch already get rich. So, and March, and now 2 months ahead of the mass production. So now we get a 16-core, 2.5 gigahertz, and it's a pretty usable RISC-V now. So everyone work on the kernel should help on RISC-V kernel, and you will write the hype. Because I think RISC-V kernel need more help than any other architectures. So for ARM, Qualcomm have a lot of money, ARM have a lot of money, they have a lot of people work on the kernel, but for RISC-V we don't. So now back to the stage. We talk about why RISC-V and upstreaming, the differences. So for ARM, whatever ARM SoC come out, they will sell millions. So they don't really care about upstreaming. Why should they care? Right? The SoC guy. And then, and for RISC-V, it's really bad. Because for now, the RISC-V, the whole software, from the kernel to the toolchain, to upper stack, whatever, is not optimized, fully optimized yet, because the hardware is not there yet. So software won't catch up. So for us, making the hardware, I have a very funny experience. 3 years ago, my 4-core machine running that time, the Debian, is very slow. But now running Debian 13, it's much more faster. It's bizarre. All right? The reason why is because RISC-V software is better and better, same hardware. So that means that RISC-V hardware, it has to live a very long silicon runtime. So that demands more upstreaming needs to be done. It lives long time. So that's why I would say that compared to ARM, RISC-V, it desperately needs upstreaming more than any other architectures. And then the other thing is that all the SoC guys, including myself, I'm making a motherboard, I have to guarantee the mass productions. So I only allowed to work on LTS. Because if I use upstream kernel, the mainline, well, I have no idea where the problem is. It's so freaky, right? If you give me a 6-20, if you knock LTS, I'm scared. Because I have no idea where the hardware problem, blah, 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 you know. So that's the hardware paradigm saying that we had to work on LTS. By the time we work on LTS, guarantee the mass production quality, and then we're off the track. We're off the main line. Probably, I remember I gave my Roma second laptop to Greg KH. I asked him, can you help me to upstream everything? He said, Liang, you have 60,000 lines of code change. No chance. I said, even Linux can't do that. But anyway, so that is the pain of it. So, and I think there's two methodology we got it completely wrong. Because most of our SoC guy and the mass production guy, we still inherit a lot of habit from ARM, which we work on LTS. But in fact, we should work on the approach same as x86. We work on mainline and backport to LTS. But that is the wrong thing we have done. So, and I give you a status. So now I give you two first generation, second generation motherboard status. So, and it's very funny. I'm not sure you guys can see it yet, you know, the old PowerPoint. And then 2018, we got the IP. And then SoC, 4 years later, we get it into the SoC. And then I take another 2 years to get into my motherboard. So it's 6 years, right? So, but you need to find out, take a look at the upstream progress. Our SoC is the first when upstream is back in 2023. It's painfully slow. So, and according to Greg KH, there's a wrong thing to do. Okay, they should have done the upstreaming since the FPGA verifications. So the last patch are still ongoing, the display with GPU stuff related. So we know, right? Linux, we know we can solve the GPU saga. Linux can, no one else can. Right? And that's it. And then average the upstreaming. And another thing is that we lack of experience of upstreaming, so it takes 10 rounds, ping pong 10 rounds to submit one patch. Okay, that's first motherboard. It's pretty much the upstreaming. Okay, and then the second one is even more awful. The CPU IPs related upstreaming is not even done yet since the IP introduced in 2020. So that's the wrong thing to do. Okay. So how are we going to do better? So I forced all my SoC guys to do more upstreaming, and RISC-V need to do better, and Greg says that as well. So this is the what Greg back in 2008 says that you need to upstream stuff from the simulations, right? That's x86 way. ARM didn't do it, right? So it's actually 15 years ago, 20 years ago, it's the experience. So, and how do we do it? So basically, I forced the third generation motherboard SoC guy. I say you had to upstream before the chip comes back, and actually it's scary because all our engineers even have experience. It's ARM cultures. They're very scared. They never done it before. So and a lot of things as well, even the maintainer we're concerned you don't have hardware. Should I allow you to submit it? So that's a problem. And the approach, we do it the simple one first, pin control or majority CPU IP related first, FPGA before, then we do easier to difficult. That's the way we do it on the K3. So, and how's the progress? So we do meet a few surprises during the process of it, during the FPGA verification and the tape out before the chip comes back. That 3 months will be a lot of surprise. So first thing, we realized that people look at the core. If we doing the kernel, then we straight away know what's the problem of the core design, hardware design. We call it big and little asymmetric. That means they have mixed cluster, RV23, one RV23, and they have different RVV. And have AI customer instruction in one. So to the software point of view, I still remember Greg's email to me. He said, Liang, you screw it up. You should let me know this diagram 9 months ago. Basically, it's very painful to get upstream and software support. So, and besides that, we have some DMA zone issue as well, 32-bit. And then the other thing is that when we start silicon upstreaming, we did share a lot of code out for all the community guys. So initially, I invited people to a private repository to look at our code. We scare off, we disclose all the hardware information before the product announced. And then at the end, I managed to convince the SoC guys that we have nothing to lose. It's bad enough. Let's open it up. Let the world see it. So that's why we open source everything, first ever. Open source everything before the chip comes out. So, and then we do pick a few rules, the FPGA target, so we make the wrong target, we submit a patch, people refuse it, and then we didn't go for any, most of the testing, we just do upstreaming without testing it, so it's very brave. And yes, if any reputation ruin, according to Greg say, nothing wrong, we just fix if there's a bug, right? Nothing shame about it. So that's what the progress is. So what can we improve it? And then I would say that we still can do better, especially for all the CPU features, we can do a lot better. So far, I forgot to bring the board. Feel free to come down to our booth. We already have the latest chip with the manufacturer sample board working. And then we still have found some major CPU feature doesn't work. For example, like hypervisor. Actually, we should have done all those software back in the FPGA stage. We haven't done all the verification. Also, we have seen that there's some AI features. We still haven't got it working. We should have done that back in the FPGA verification at that time, and also upstreaming at that time. Then we pretty much get everything ready, but now we haven't got it. So there's still a lot of things to improve. And of course, now we learn SoC, you have to have consistency. We use as many as you can. So for Space MIP, the K3 and K1, they have share majority is 60%, 70% the same IP. So all those upstreaming effort for K1, and we use most of the upstream effort from K1 anyway. So it's much more faster. So that's all for today's talk. So, and this first ever, I think we have done better than ARM, including Qualcomm. And we continue to do better for less chip, for the server chip, and because there's less IP involved. And look forward to you guys' help, and especially we need it in RISC-V, we allot enough resources. Thank you. Any questions? Yeah, you can go up to the GitHub and take our upstream patches. It's not done by me, done by the SOC guy, but they're very brave.
Any questions? Yep.
Hi, thank you for your talk. Regarding upstreaming, is the data sheets of all these processors that are you interested in to go upstream, is it easily available for download?
Yes. Whoever that want to help upstream, we will release all the data sheet, and including our schematic.
Nice, thank you.
We have to do better than now. I have no secrecy. We should have no secrecy. RISC-V have no secrecy.
Other questions?
So to come up to the upstream kernel log, we did pretty well actually. The SOC guy did about tens of patches before the chip comes back. Very brave. Whether it works or not, I don't know.
Not really a question, but more of a comment. So we maintain, we have TH1520 RISC-V SoC at Scaleway, and we have to maintain an all fork of the kernel because of that, because of the lack of upstreaming. So having upstream patch mainline, it's something that will benefit all of us.
Yes. I think definitely we will upstream as much as we can, except the GPU. GPU, I can't deal with it, man.
So I have no experience from working on a CPU, but working up from a device side, we made quite a good experience by implementing it in QEMU and doing a software simulation. And then we had in driver stuff and so on pretty good shape when we had the hardware ready. I don't know how it works out for RISC-V. Probably it's too complicated.
I think it's very complicated because I think using simulator, same as I'm a VM guy. Usually I do simulator first before I touch the hardware. Otherwise, stupidity, right? But we think that because so much peripherals, we have codec, we have too many, man. Jesus Christ, right? So those one we only can emulate majority of the CPU features, okay, hypervisor, blah 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 blah. And AI, those things are okay. Should go into simulator and then start upstreaming, and then the FPGA, and then also as well. So that we should do better, seriously. But the rest of the code that or I/O and leave it to hardware. All right. CPU side, we definitely can do better. Thank you.
All right. Out of time. Thank you.
Thank you very much. Thank you.
Microphone.